we have come. The moment you've all been waiting for. This is the point of kind of the earlier ones. Let's verify some trig identities. So graphically, we've shown that if you graph one side of the identity, it should look like the other side of the identity. We did that with Desmos, right? Specifically, you know, over here, over somewhere, I can't find my mouse. All right, we graphed one part, and then, yeah, that's what it equaled. All right, so I'm going to give you a step-by-step, like, set of tips. Again, there's no single way to always do these. Just some tips that help me, and so hopefully they help you. All right, so when you're verifying identities, you're going to always start with one side. And that's usually going to be the messier side. And then try to get it to the other side. Try to make it look like the other. We can only work with one side at a time. So we try to get the messier one and then use some tricks, use some simplifying and stuff like that to try to get it to look like the other one. So kind of like driving, look where you're going, okay? Look where you're going, walking to. Like, look at what you want, right? So if the right-hand side has a bunch of cosines in it, maybe you want to make the left-hand side have more cosines. You can use the Pythagorean identity to turn sine squareds into cosine squareds and stuff like that. All right. And then just try to simplify. You know, in general, simplifying is a really good strategy. Simplifying makes things simpler. Okay. And one rule of thumb that is usually a good idea is just put things in sines and cosines. It usually makes things easier to work with. So when in doubt, sine and cosine it out. So this is kind of a rough outline of how to approach these problems. So let's try to do it. Example 7. Verify the identities. Part A, tangent of theta times cosine of theta equals sine of theta. And maybe you don't trust me. Maybe you say, Jason, I'm not convinced this is even an identity. I don't even know if I want to waste my time verifying it. Well, you could kind of go over here, remember, and you could say, well, let's look at the left-hand side. Is the tangent of an angle times a cosine of that angle, is that equal to sine? Wait, it's giving me an error. What is it unhappy about? All right, it wants parentheses right here. Oh, tangent times cosine? Well, that sure looks like sine. Is it? Oh, yeah, it is. White and blue graph are the same. Neato. So, what were our step-by-step process? Our little guide, rough guide. Start with the messier side and try to make it look like the other one. So the messier side, they're not that bad. The messier side is the left-hand side. We're going to say, let's start with the left-hand side. And again, this is a common abbreviation. LHS and RHS. I'll be using these all the time. The left-hand side is the red thing. We want to turn it into, look where we're going. Don't be like me, driving on the 5 in Washington, and I see Mount Rainier and I go, oh, that's pretty. Don't do that. Look where you're going. It really is a beautiful mountain though. And then try to simplify, and when in doubt, put things in terms of sines and cosines. So this has no sines, but where we're going, we want to get some sines. So let's write tangent as sine of theta over cosine of theta, and that's being multiplied by cosine of theta. Oh, great. Cosine divided by cosine cancels out. We're just left with sine of theta, which is equal to the right-hand side. We started with the left-hand side. We did some mathematical magic, and we showed that the left-hand side, all of these steps are correct. Left-hand side is equal to the right-hand side. Ta-da! That's all there is to it. Now, obviously, the problems are going to get much harder, but that's the logic. Part B. 1 plus sine of x times 1 plus sine of negative x equals cosine squared of x. Again, we're going to want to start with the messier side. We're going to start with that left-hand side. There's not that much we can do with the right-hand side. We could use the Pythagorean identity, but it's always easier to collapse things than uncollapse them. It's like the opposite of real life for trig. So there's two things. First off, I see a negative x and I say, let's deal with that. All right, sine is odd. So it equals negative sine of x. Let's start with that. Anytime you have a negative x, that's a really good place to start. This turns into 1 minus sine of x. This is the difference of squares formula. You could FOIL this out the long way, or it's the first thing squared minus the second thing squared. Oh, Pythagorean identity comes in again. All right, sine squared of any angle plus cosine squared of that angle equals 1. So if we subtract sine squared from both sides, cosine of any angle is 1 minus sine squared of that angle. Same thing. This is equal to cosine squared of that angle by the Pythagorean identity. And that is the right-hand side, which is exactly what we wanted. You could have one check mark. You could put a little second check mark. Or you could have a cool check mark guy. Cool check mark guy. Let's do part C. See, notice I don't think these problems are any worse than the last video. The last video are probably way worse. It's the simplifying, it's the algebra. It's not really the trig that much. A little bit of the identities maybe, but the algebra is the big culprit here. So let's do some messier ones. Secant squared of theta minus 1 over secant squared of theta equals sine squared of theta. Again, we're starting with the left-hand side. Left-hand side's messier. Now, I think there's kind of two ways that make sense to approach this. This looks similar to a Pythagorean identity. All right, secant squared of theta minus 1, is that one of our Pythagorean identities? Scroll to the top. Secant squared, if we subtract 1, secant squared minus 1 is tangent squared. So we could just say, that's tangent squared of theta. That's one way of approaching this problem. Another way of approaching this problem is splitting up the fraction. So this is what I'd recommend, but I want to show another point of view. The more ways that I can show you to approach these problems, hopefully the better you're going to be able to look for different things. You'll have seen more strategies. So, right, so subtraction on the denominator would be a problem, but subtraction on the numerator is fine. We can split this up, and if we split this up, we're going to get some nice cancellation. Right, this first thing cancels completely to 1. Secant is the reciprocal of cosine. So this becomes 1 minus cosine squared of theta. And again, we're going to use the Pythagorean identity. 1 minus cosine squared of theta is sine squared of theta. And there's a lot of ways to see this last step. Oh, we're not boxing that. That's equal to the right-hand side. Cool check mark guy. Bunch of different ways of doing this. Real quickly, right, if we did the other way, become tangent squared of theta over secant squared of theta. Tangent is sine over cosine. Dividing by secant is the same as multiplying by cosine. And you could get sine squared that way too. Let's do 2 more. 1 minus cosine squared of x times 1 plus cotangent squared of x equals 1. Again, we'll start with the left-hand side. And these are really fun to do in a group. So it kind of sucks that we're in an online format with these videos because there's a ton of different ways of starting this. One way of starting this would be to just FOIL it out. It'd be messy, but it'd work. It's straightforward to just FOIL this out. Another way of starting it would be to say, let's write cotangent in terms of sines and cosines. Why is that useful? Because we'll have actually, it's not really useful. It's going to be cosine over sine. We're not going to get any cancellation. It would work, probably wouldn't be that helpful. Another thing to do is, can we use Pythagorean identities to simplify? If we use Pythagorean identities, we might not have to FOIL at all. And that's what we're going to choose. So the 2 relevant Pythagorean identities, sine squared of x plus cosine squared of x equals 1, and 1 plus cotangent squared of x equals secant squared of x. The other one's always kind of, 1 plus cotangent is, 1 plus cotangent is cosecant. It's always paired with the cos. So the co on this goes with the co in that. That's how you can remember. That's great, right? Because 1 plus cotangent, we have that. It's cosecant. 1 minus cosine squared, we don't really have that, but we could get it. It's going to be sine squared. So this is really just sine squared of x times cosecant squared of x. And remember, cosecant squared is just 1 over sine squared. Don't box it. This is equal to the right-hand side, which is what we wanted to show. Check mark. Double check mark. Cool check mark guy. Last one. Cosine of theta divided by 1 plus sine of theta equals 1 minus sine of theta over cosine of theta. I don't think either one of these is really messier than the other. If anything, the left-hand side is messier. Because there's addition in the denominator, and addition in the denominator is usually bad business. All right? But we have a sign in the denominator. There's nothing to simplify, right? The left-hand side, there's nothing really to do. So we're kind of stuck. Let's look at our strategies. We started with a messier side. We already did that. Look where you're going. Look at what you want. So we want a cosine in the denominator. We have a sine. How do we get a cosine? We looked at this in the very beginning, maybe the second video, I don't remember. We've looked at this before. This is where we're going to need that trick. We want a cosine in the denominator, right? How can we get a cosine? The only real way for us right now to get sine of theta into a cosine of theta is with a Pythagorean identity. But Pythagorean identities only work with sine squared. What we're going to do is we're going to do that trick from earlier. How do we get a sine squared? Well, we can multiply by sine of theta, but then we're going to have some other problems. So we multiply by the conjugate, 1 minus sine of theta. By doing this, we'll have access to the Pythagorean identity. So in the top, we're going to leave it factored. You can distribute out the top. The only reason I'm leaving it factored is I remember our example from earlier, but there's no problem if you distribute it out. And on the bottom, that's a difference of squares. Well, the bottom simplifies real nicely. Pythagorean identity. Top remains unchanged. You may have to factor it again if you did distribute it. One of these cosines cancels with one of these cosines. We're left with 1 minus sine of theta over cosine of theta. And now I don't know what to do. There's not really an easy way to simplify this. We could maybe split up the numerator. And yes, I'm tricking you to show a point. Remember when you're doing these, don't lose sight of where you're going. Don't tunnel too hard. We're done. We finished. This is exactly what we wanted to show. So when you're verifying identities, it's a good idea to always remind yourself of where you're going. Don't stare at Mount Rainier on the highway. That's dangerous. Look where you're going. This is the right-hand side. This is exactly what we wanted. And there's nothing to box. We're not boxing our answer here because our answer, we're verifying an identity. Our answer is this proof. If you boxed anything, this is what you'd box. And again, you can always verify these identities graphically as well. Wait, that's the end. That's the last one. That's the last problem. Go get verifying. Have fun. Enjoy it. Use those identities and let me know if you have any questions.